This video will run through the final section of time series for data analysis in Further Maths, looking at seasonal indices. And so firstly, what is a seasonal index? So we use a seasonal index when we have time series data that has a clear seasonal pattern. And so it's an indication, the index itself is an indication of how that one particular season compares to others. And so we usually are provided the data in a table, and we go through a process of what we call deseasonalising the data. So it's a technique of smoothing, but it's specific to data that has that seasonal variation. And we've got an example here of fines collected over a quarterly period for 3 years. And we can see that we've got this clear sort of cycle happening, and it's happening within that 12-month period. So that means we've got seasonal variation. The green line here is then the deseasonalised data that has been plotted. So the advantages here, unlike smoothing, we don't lose any data points, and it has a better effect than smoothing does when you've got that cyclic nature. And so that makes it better for making predictions, so using a least squares regression model if our data is more tending towards a linear form. And so a seasonal index itself compares that particular value to the average for that season or from the time period being considered. So I've just got a little snapshot here of 1 year worth of data, and the green line through the middle this time is actually the average. So the average for that single year. And so any value above that green line would have a seasonal index of more than 1. And anything below the green line would have an index of less than 1, so between 0 and 1. And this last one that's exactly on average would actually have a seasonal index of 1. And so the index value for that particular season is a proportion of the average. So throughout this video, we're going to have a look at how we actually calculate seasonal indices. Couple of key points to know at the moment. So the average of all the seasonal indices itself must be 1, and the sum of all the seasonal indices equals the number of seasons. So for example, if we were looking at a seasonal pattern that was occurring measured monthly, and therefore we were finding seasonal indices for each month of the year, then the sum of those indices would equal 12 because there's 12 months in that one cycle or that one time period. The example we've got here, we've got the seasonal indices for the daily earnings in a cafe in a tourist town from Monday through to Saturday, shown in the table, and the seasonal index for Sunday is not shown. And we want to use the information we have there in the table to calculate the index for Sunday. So as we said, the sum of the indices must add up to the number of seasons that we have. So in this case, if we've got days of the week, that tells me that I've got 7 seasons. And so that means the sum of these indices here, what we have, including Sunday, so the sum must equal 7. So to find out this missing value of Sunday, what we need to do is add what we do know and subtract that from 7. And so when we do that, we find that Sunday has an index of 1.62, meaning definitely above average, and it's actually the highest value above average for the week. So following on from that, we look at how we interpret seasonal indices. So as we know, the seasonal index is a proportion. The seasonal index value, if it is below 1, will mean that that particular season or day, in this case, is below the average. If it is exactly 1, then it is equal to the average. And if it is above 1, it is above the seasonal average. So I tend to use this little formula here, where I can take the index and turn it then into a percentage. So in this case, if I get a negative value, so a negative percentage value, that tells me that the index is below average. If I get equal to 1, obviously still the same. And if I get a positive percentage, then I am above average. So if we look at the example here, the seasonal index for Wednesday is 0.74. What does this tell us about Wednesday's earnings? So if we check our little calculation, so Wednesday's index of 0.74, if I subtract 1 and multiply that by 100 to make a percentage, I end up with negative 26. So what that tells me is that the sales for Wednesday, or the earnings for Wednesday, are 26% below the daily average. And so the important thing here is that you're identifying it is below and by how much, what percentage. Often these are multiple choice questions. And so the other interpretation could be that Wednesday's earnings are 74% of the daily average. So not necessarily what the change is, but what exactly does that 0.74 represent. So in that case, it's just turning that into a percentage. The next application we need to consider is when we are correcting for seasonality. So what that means is that I have my seasonal indices and I'm being asked how might I need to adjust that particular time period, that particular season, to bring it back in line with the average. Now, be really careful here. It is not as simple as saying, well, if the index is 0.8, it is 20% below average, so therefore I need to increase the earnings or the sales by 20%. Please don't be caught out with that. What we will need to do is use the formula that we've got here. So it's 1 divided by the seasonal index that we're trying to correct, minus 1, and then times by 100. And that will give you the percentage correction required. And so again, if that percentage is positive, you will need to increase by that amount or that percentage. If the answer is negative, you will need to decrease by that amount. So looking at the example we've got here, the same table of seasonal indices, and it says the seasonal index for the daily earnings on Friday is 1.12. To correct for seasonality, what adjustment must be made? So hopefully we can already recognise that 1.12 is above average, so it's going to need to decrease. But the question is by how much? And so using the formula, we would say 1 divided by 1.12, so our known index, take away 1, and then times by 100 to make a percentage. When we do that, we get negative 10.71. And so that means I'm going to decrease, because I've got a negative, by 10.71%. So notice there it's not 12%. It's not that sort of catch-out answer. So just be really careful with that. Okay, so now we're moving on to calculating seasonal indices. If we've got a single cycle of data, then it is just a two-step process. More often though, we have multiple cycles of data, and we'll look at that process in a little later on. So firstly, the two-step process. The first step is always calculating the average for that cycle length. And then in this case, we're then going to calculate an index by using this formula here. The original value for the season divided by the average for the season. So let's have a look at how that looks like. So the example we've got here, we've got a table below recording the monthly sales in thousands. And we're going to use the data to determine the seasonal indices for the 12 months shown. So just a quick reminder here, we've been told it's seasonal data. We have just one single cycle. There are 12 months, so a season in this case is a month. And so all of those indices, once we find them, they should add up to 12 in total. So if it was just one missing, that would be a nice easy job. In this case though, I need to go through the steps of calculating. So firstly, I calculate the average for the cycle. So that means I'm going to take all of these sales values and add them up. So literally 12 plus 13, 14, so on, up to the values for November and December. And then I would divide all of that by 12. When I do this, I get a cycle average, or a yearly average in this case, of 13.5. Now to calculate each of the seasonal indices, so for each month, what I'm going to do is take the actual sales value for the month, divide it by my yearly average, or my cycle average that I've found there. So, for example, in January, that means I'm going to do 12 divided by 13.5, which gives me a value of 0.89. In February, 13 divided by 13.5, which gives me a value of 0.96. Now, I am rounding each of these indices off to 2 decimal places in this case. Some of them are not terminating there, but for the sake of being able to do this here, you will always be told what to round your values to unless they are terminating. So if you're not told, then by some magic they will all round off to a nice number, but usually you will be told here. Okay, so I've continued along and done the same set of calculations each time. So just as a little reminder as well, so for December, that would be found by doing 20 divided by the average 13.5, giving me 1.48 as my index for December. Now, most often you have multiple cycles of data, and so this becomes a 3-step process. What we're doing initially is the same. So we're finding the average for each cycle. So whether that's each year, usually each year, or sometimes each week, whatever the period length is there. The next step is to calculate their proportion for each season within the cycle. So that would mean taking each of those values and dividing by that average for the cycle. So much like we did before. The final step is then to calculate the average seasonal proportion, which is now the seasonal index. So that would be if I had 3 years worth of data and I had monthly data for those 3 years, the first 2 steps are relatively the same as if I had a single set of data. The third step would be taking each of those proportions that I found for January and averaging those 3 proportions to get an overall index for January. And we would repeat that for each of the seasons within that particular set of data. So let's have a look at an example now. So the data we're using this time, shown in the table below, is the number of new gaming apps released each quarter from the beginning of 2014 to the end of 2016. So we want to use the data to determine the seasonal indices for each quarter. So in this case, we're going to repeat those first 2 steps for 2014, 2015, and 2016. And then finally, we're going to take the values, those quarterly proportions, for each of the first quarters and average them. Do the same with the second, the third, and the fourth. So we'll run through all of that. So our first step is calculate the average for each cycle. So in this case, one cycle is 1 year worth of data. So I'm actually going to calculate the yearly average. So that means here for 2014, I'm finding the average of 43 plus 45 plus 54 plus 81 and dividing that. So I'm going to add those together and divide by 4. And that gives me a yearly average for 2014 of 55.75. I repeat this now for 2015. So again, 51 plus 50 plus 60 plus 89 and divide by 4. And I get a yearly average of 62.5. And finally, 2016, 57 plus 52 plus 69 plus 103 divided by 4. And I have 70.25. It's my yearly average there. So now that I have my yearly average, I need to calculate the quarterly proportions. So here we've got a mostly filled table, but just a couple of examples that we can do. And so remember, to get this proportion, I'm taking the original value, so 54 for quarter 3, 2014. I divide it by the average for 2014, so 55.75. And there I get, again, rounded to 2 decimal places, a proportion of 0.97. So it's almost the same, not quite, and you can tell that there. This one here, I'm now working with quarter 2 in 2015, so the actual value of 50 divided by the average for 2015, so 62.5, and I get 0.80 there. And finally, quarter 4 in 2016, so the actual value of 103 divided by the yearly average of 70.25, and I get an index, or sorry, a proportion there of 1.47. And so now looking at step 3 in this process, I'm going to calculate the seasonal indices. And so I've just picked up the table from the previous slide and put that in here. And so now I'm going to firstly calculate the index for quarter 1. So we use a bit of colour to help us here. That means I'm going to pick up the proportions from each of the quarter 1s and average them out. So here I would be doing 0.77 plus 0.82 plus 0.81 and dividing all of that by 3. And when I do that, I get an index then, so on average, quarter 1 has a seasonal index of 0.8. So that's 3-year set of data. I would then repeat this. So for quarter 2, I would take the value 0.81, 0.8, 0.74, add those 3 values together and divide by 3 to get the average, and I get 0.78. Again, quarter 3, I've got 0.97, 0.96, 0.98, quarter 3, and when I average those, 0.97. Finally, quarter 4, 1.45, 1.42, 1.47, and that gives me an average of 1.45 as my index. So once I've gone through the process of identifying or calculating the seasonal indices, the next step in the overall big picture of this process is to deseasonalize our data. And that's the process of smoothing our data or taking out that seasonal effect. So it's a little bit like smoothing, it's a little bit like data transformation that we've looked at so far. But how we deseasonalize our data is by actually taking our original values and dividing them by the seasonal index. And what that does, as we saw at the example way back at the beginning, it allows for a more linear representation of the data, making any least squares regression models we use to help us interpret the data or to make predictions much, much more reliable. And so continuing with the gaming app numbers data, we're going to move through and deseasonalize that set of data. And so using the little formula here, we're going to go through, and each quarter 1, we're going to take the original value, so the original app numbers, and divide that. So quarter 1 is all going to be divided by 0.8. And so here, that would mean in 2014, we'd be doing 43 divided by 0.8, which would give us, to the nearest whole number, 54. In quarter 1 of 2015, the same process, 51 divided by that same index, 0.8, and that will bring us up to 64. And quarter 1 in 2016, so the original of 57 divided by 0.8 would bring us up to 71 as a deseasonalized value. What we should see, where the index is below average, so it's 0.8 is 20% below average, our deseasonalized values will be brought up in line, so they will increase to be brought up closer to the average value. So anything above average, if we're now to look at quarter 4 using the index 1.45, when we do those calculations, so 81 divided by 1.45, and again, rounding to the nearest whole number, we get 56 as our deseasonalised value. So these are being brought down in line, more in line with our yearly averages. Okay, so bringing those values right down in line. And finally, 103 divided by 1.45 brings us to 71. And so if we go ahead and complete that for quarter 2 and quarter 3 as well, we will have our full set of deseasonalised data. And so there's our full set of data. Again, all of those have been rounded to the nearest whole number. And if we look at what impact that has had, and so here is just a quick graph of the original data in the maroon colour, okay, and our deseasonalised data in the green. So if you imagine that I asked you to put a regression equation on that original data, you can still get a regression equation, but depending on what quarter you were then asked to make predictions for, you might have really massive residual values. So that would make your data more unreliable. Whereas the green line, it's more consistent, and so any predictions or any models created using that would be more reliable than the original. Okay, so how do we go about creating that least squares regression model? We're going to look at 2 examples. One is when I've got just regular time series data without seasonality, so I don't have to apply this deseasonalising. Just a couple of pointers. Remember, you still want your time series data to have some sort of linear trend, otherwise it's not appropriate to apply a least squares regression line. If your data isn't given as a numbered code, you would need to enter a time code into your calculator for the explanatory variable. So for instance, if the data is Monday, Tuesday, Wednesday, we would number that off from 1 through to 7 or 14 or 21, depending on how many pieces of data we have. And then we calculate our least squares regression line and make predictions as we normally would. And so our example here, we have yearly traffic congestion levels for Melbourne is shown in the table below. So we've got from the year 2008 through to 2016 and the congestion levels as a percentage there. We want to firstly use the data to determine the least squares regression equation, giving our answers to 4 significant figures. And then we're going to use that equation to make a prediction of what is expected to happen in 2022. So let's go across to our calculator and put that data in. Okay, so you can see here I've entered that data in and I have just put the actual year. So I didn't need to use a time code there. If you did use a time code, that's okay. It's just when you go to make a prediction, you have to know what you have put in. Usually in an exam situation, they'll be really specific about how to enter it. So they'll either tell you to use a time code if it's not an expectation that you're just numbering it like I have here as the actual year. Okay, so I need to calculate my regression equation. I may choose to do that by looking at the scatter plot, or I can do it just from this page. So from this page, when we're going menu, statistics, stat calculations, and always number 4 to the form a plus bx. My x list is the year, my EV, and the y list is my congestion level that I've just put it in as CL. And so when I get those values, I've got a value of A, so minus 1,514.76, and a value of B, my slope, 0.767. So I would write those down unrounded and then give my final answer correct to the 4 significant figures that I've been asked for. Okay, so there's our equation in terms of the variables and to 4 significant figures. So part 2, I'm going to use this equation to make a prediction of the congestion level in 2022. So I'm literally going to substitute into my equation 2022 as my year. And so when I calculate that, I end up with a congestion level of 35.2674%. So for these, and following on from what we've got in the table, let's say 35%. When we do have data that has that seasonal variation, Generally, we are given the data in its deseasonalised form. So they've already gone through, deseasonalised the data, and we receive that as the values to work with. And so that means our deseasonalised data becomes the response variable, the RV, in our calculator and in any calculations we do. What that means, though, is that when we make predictions, we generally need to re-seasonalise any predictions back to the original actual form. And we do the opposite of what we did earlier on with calculating the seasonal indices, and use this formula here where we're finding the actual value is equal to the deseasonalised value times the seasonal index. And so all of that information will be provided to you in the questions. Okay, so we're running through with the same gaming data app information that we had from the previous examples. And what we're being asked to do first is find the least squares regression line for the deseasonalised data. So that means I'm going to enter this data here as my RV list, the deseasonalised data. The other thing with this set of data as well is I'm going to need to use a time code. So I cannot just enter 1, 2, 3, 4, 1, 2, 3, 4 and repeat, because remember in time series data, I want one single explanatory variable, so one single X value for every response. And so in order to do that in my calculator, I'm actually just going to number these off just in numerical order. And so then when I need to make predictions later, I will just have to count forward to work out what value it is I'm going to substitute in. So firstly, let's put this data in our calculator and we'll find our regression equation. Okay, so there's my data. And see, we've got our quarter just as numbered off and the deseasonalised app data there. So this time I am going to use the alternate method. So I'm going to draw us a scatter plot. So if I insert a data and stats page, I'm going to pick up my quarter from my list there and the deseasonalised app data. And so there, and if we want to make that a proper time series with the lines, there we go. So it's not perfect, the deseasonalising we're seeing on this scale, but it's certainly better than the original data. And so now if I want to put a regression equation on that, then we go into Menu, Analyze, Regression. We want to show A plus BX linear. So there's my regression equation there. And so what I need to make sure I'm doing when I'm writing this least squares regression equation down is putting in terms of the variables, so not writing y and x in my equation. And so when I write that, I've just gone correct to one decimal place for this example. Even though I've used a time code, I can still put in quarter as my variable there. And so now we want to use that regression equation to make a prediction. And this time I'm making a prediction for the second quarter of 2018. And so remembering that the final value I put in, so the quarter was the 12th time code there. So we need to count forward to the second quarter of 2018. Okay, and that can literally be just making a note on the side and counting your numbers forward. So if I'm at 12 here, then I would have quarter 1, 2, 3, and 4 in 2017. So that would get me to 16. Quarter 1, quarter 2. So that would mean I'm actually substituting in the quarter is number 18 for that set of data. Okay, so when I put that in and get my prediction, what I'm going to have is the prediction for the deseasonalised data. Okay, so I get a value there of 81.6, but that, please remember, is your deseasonalised apps data. So the final step in this process is to now re-seasonalise that because they want the actual number. So we need to go back to our quarter 2 index, and so the actual app data will be our deseasonalised amount, 81.6, multiplied by our index for quarter 2, so 0.78. And so when we do that, we get an actual predicted app number of 63.648. So let's say closest to 64 apps released in that quarter. Okay, so that's it for our seasonal indices section. A large number of applications and processes there for one tiny little section of the course, but it is important that you have some good notes for yourself so that when you do come across this, you feel confident you can tackle it. Best of luck.